In this class, we'll see the properties of discrete time Fourier transform. In the last class, we have seen the basics of discrete time Fourier transform, and also we have seen the discrete time Fourier transform of some of the basic signals. In this class, we'll see the properties of discrete time Fourier transform. Almost all the properties given here in the discrete time Fourier transform is something similar to the continuous Fourier transform, except some difference. Okay. In particularly in these properties, we will not have the differentiation in time domain properties, because we know that x of n is discrete and the discrete time Fourier transform is x of e power j omega, but it is continuous. That means in time domain we cannot do the differentiation, so that we will not have these properties, because x of n is discrete, so that we cannot have the differentiation property in time domain, but we can have the differentiation in omega domain. So this is some main difference between the discrete time Fourier transform properties and the ordinary Fourier transform properties, that is continuous time Fourier transform properties. Okay, we know that linearity x1 of n is the discrete time signal. For that, the discrete time Fourier transform DTFT is x1 e power j omega. For a signal x2 of n, discrete time Fourier transform is x2 of e power j omega. Now, what is the linear combination of these two signals? That is a x1n plus b x2n. For that, the Fourier transform is ax1 e power j omega plus bx2 e power j omega. Then the proof for this: the discrete time Fourier transform of x of n, okay, the small f of x of n means discrete time Fourier transform, whereas capital F of t will be using for continuous time Fourier transform, and simply the notation f, small f, will be using for discrete time Fourier transform. Okay, so now the discrete time Fourier transform of the discrete signal x of n is equal to summation n minus infinite to plus infinite x of n e power minus j omega n. Again, here we are having the linear combination of signal, that is f of ax1n plus b x2n. In here summation n minus infinite to plus infinite, instead of x of n we are having this expression, that is a linear combination a x1n plus b x2n multiplied with e power minus j omega n. Again we can split up this summation n minus infinite to plus infinite. Again a is a constant, we can take outside, x1 of n e power minus j omega n plus b summation n minus infinite to plus infinite x2 of n e power minus j omega n. Again we know that this is the discrete time Fourier transform of the signal x1 of n, so that we can write like f of x1n, and this one we can write like b f of x2n. Okay, so finally this is a x1 e power j omega plus b x2 e power j omega. So what is the next properties? The next property is time shifting property. Time shifting. And again, we know that shifting in one domain is the exponential multiplication in the other domain. So that is x of n is the discrete time signal. For that, we take discrete time Fourier transform, that is x of e power j omega. Suppose if the signal, original signal x of n is shifted by some amount, that is n naught, by the right side, then what is the discrete time Fourier transform of the shifted signal with respect to this one, that is e power minus j omega n naught x of e power j omega. proof. Discrete time Fourier transform of signal x of n is equal to summation n minus infinite to plus infinite x of n e power minus j omega n. What is the Fourier transform of time shifted signal, that is x of f of x of n minus n naught? That is summation n minus infinite to plus infinite x of n minus n naught e power minus j omega n. Again, we can substitute n minus n naught is equal to p. Okay, let's take let n minus n naught is equal to p. Again, we know that n is variable, but n naught is constant. So p is variable. So from this, we can write n is equal to p plus n naught. Okay, then once if you replace with this, again the limit, okay, the limit varies from n minus infinite to plus infinite. That's why again the new limit p also will vary from minus infinite to plus infinite. Again, instead of n minus n naught, we can substitute p x of p e power minus j omega. Instead of n, we can substitute p plus n naught. So p plus n naught. Again, from this, this is with respect to, everything is with respect to p. Again, we can take e power minus j omega n naught outside separately. Okay, then summation e power minus j omega n naught, summation p minus infinite to plus infinite x of p e power minus j omega p e power minus j omega n naught. This is something like discrete time Fourier transform of signal x of p. Okay, and please remember the discrete time Fourier transform of signal x of p is same as the discrete time Fourier transform of signal x of n, where p and n is just a variable. So whether I use p or n, definitely finally I will be getting the same answer. This is just variable. It is something similar to the notation x will be using in mathematics, t will be using signal system, but in both the cases we'll be getting same answer. It is just your notation. So that's why again I can also replace this. Instead of x of p, I can also write like x of n. So you'll not get any change in the answer. So finally I can write like x of e power minus j omega n naught and then x of e power j omega. So what I'm trying to say here, see, for x of n, I am writing discrete time Fourier transform as x of e power j omega. Suppose if the signal is represented like x of p, for that if I take discrete time Fourier transform, then also I will be getting x of e power j omega, where n and p is just a variable. Okay, so what is important finally, the shape of the signal is important, not the variable. See, remember, n is also a discrete variable, p is also a discrete variable. Okay, discrete time variable. So whether I use n or p or some other variable, still I'll be getting the same answer. Okay, so don't get confusion that whenever I'm getting x of p, directly I will write like x of n. Everything is almost finally everything is same. Okay, so the next property is frequency shifting property. Frequency shifting. Again, we know that shifting in one domain is exponential multiplication in the other domain. X of n discrete time Fourier transform is x of e power j omega naught n. X of n is equal to x of e power j omega minus omega naught. Okay, here the shifting is in the frequency domain. So that means what? The spectrum in the frequency domain is shifted by the constant amount of omega naught. Then what will happen to the time domain signal? The time domain discrete time signal will be multiplied by e power j omega naught n, where omega naught is constant. Okay, omega naught is constant. Okay, then proof. Discrete time Fourier transform of signal x of n is equal to summation n minus infinite to plus infinite x of n e power minus j omega n. In discrete time Fourier transform of signal f of e power j omega naught n x of n is equal to summation n minus infinite to plus infinite x of n, again e power j omega naught n. Already e power minus j omega n is there, e power minus j omega n. Now we can combine these two terms, summation n minus infinite to plus infinite x of n. Again, we can write like minus j omega minus omega naught n. Just I'm writing in the standard notation, because whenever e power is there, we'll be having e power minus j omega n like that. Okay, so finally we'll be writing e power minus, sorry, x of e power j omega. So except that minus n, we are writing the remaining terms here. So to maintain that same notation, I'm just using like this. Okay, otherwise I can also flip this. Okay, but we have to have this minus j and outside. Okay, so then that means what? Finally, this is the this we can represent like x of e power, except what is there, except minus j, and what is there that we can represent here, that is x of e power j omega minus omega naught. Okay, so next property is time reversal property. Time reversal. X of n, discrete time Fourier transform x of e power j omega, x of minus n is x of e power minus j omega. Proof. F of x of n is equal to summation n minus infinite to plus infinite x of n e power minus j omega n. What is the discrete time Fourier transform of x of minus n? Summation n minus infinite to plus infinite x of minus n e power minus j omega n. That means what? Our signal, instead of x of n, we are having x of minus n. That x of minus n we are substituting here, because whatever the signal that is present here will be substituting here. So here now we are having x of minus n. So same thing we are substituting here, x of minus n. Again, everything else is same. So then again, to maintain with the standard notation, okay, we'll substitute, we'll take p is equal to minus n. That means instead of minus n, we'll substitute some positive variable, that is p. So p is equal to minus n. So then what happens when p is equal to minus n? Again, the summation goes from minus infinite to plus infinite. Then definitely p will be going from infinite to minus infinite. Whether we go from minus infinite to plus infinite, or from plus infinite to minus infinite, everything is summation only. So again, the new summation p is going from, in general, it is going from infinite to minus infinite. Then x of minus n we can replace with x of p, then e power j omega p. Again, to maintain with the standard notation, because we have to get minus j n. Again, instead of n here, p is there already. I have told you, whether we use n or p, no problem. But you have to maintain this negative minus j and variable standard. So this we can write like summation x of p e power minus j omega minus p, because minus into minus is plus. Okay, so then again, this summation, whether we go from infinite to minus infinite, or from minus infinite to plus infinite, everything is same. So this I can also write like p goes from minus infinite to plus infinite. Then finally I can write like this is something x of e power, then what is the variable here? Again, this minus we have to use with this omega, because here we have to use the standard. Okay, minus n, except minus n minus jn, what is there? Omega is there. That omega will be using in e power j omega. So that means that minus we can take with this minus omega. So that one more minus I am taking with omega, then ERP. So except minus JP, I can directly write that is e power j, then minus omega, so that I can write like e power minus j omega, e power minus j omega. Okay, thank you.